Howdy Huskies, we're going to go ahead and do part 3 today. So the major difference between part 2 and part 3 is that you're going to notice that we're going to have two variables. We're going to be finding both sides, okay? So the idea is that we're going to be able to find all the sides of a triangle. So our first thing that we're super important of is to keep using this to help us out, making sure that we are all set up, ready to rock and roll, okay? So the idea is that you want to use two trig functions. We're going to use two out of the three. And what you don't want to have is some trig of theta is equal to y over x. So this is going to tell us that that's not going to be all good for us because we can't solve that. You with me? So let's go ahead and take a look at our first one. So the first thing we're going to do is we're going to label our triangle. So this is our hypo, just like we did in the previous video. Then we find our theta, and we say the closest side is going to be our adjacent. And then last but not least, we're going to go to the opposite side here. And now we're all set. So we have everything all nice and labeled. So we're good there. So then when we go ahead and we look here, remember, we're going to use two of the three. So which ones are going to give us this x over y that we don't want, or y over x? So notice that opposite and adjacent is where our two variables are. So which ones have an O for opposite and an A for adjacent? That's tangent. So that tells us that tangent is not going to be one of the trig functions that we're going to use. So we're going to start off with the first one, which is going to be sine. So sine of our theta is going to be opposite over hypo. So the sine of 54 is going to be opposite, which is x, over hypo, which is 8. So we're going to put this over 1 and cross multiply. So 1 times x is going to be just x. And then sine 54 times 8 is going to be 8 sine 54. Now, hopefully you're getting pretty good at your calculator where you can do this all in one fell swoop. You don't need to write the decimal anymore. So an example on this TI that I have here, I would just go 8 sine and then 54, close my parentheses, and then it gives me my answer that x is going to be 6.472. We don't have to use the decimal anymore. That's going to make just things a little bit faster. Cool? Now we'll go ahead and use our cosine. So cosine of our same theta is going to be adjacent over hypo. So the cosine of 54. Yes, your theta should always match. We're using the same angle, okay? Is going to be equal to y over 8. So then we'll put this over 1 and cross multiply. So I'm going to get 1 times y, which is just y. And then 8 times the cosine of 54. So y is going to be 8 cosine 54. So when we put that into the calculator, we're going to get 4.702. So what I like to do is at this point in time, I'm going to do a quick check to make sure our answers make sense. Remember the triangle inequalities that says the largest angle has to be opposite the largest side? So this is our 90-degree box. This is 8. So largest angle, largest side. Okay, so that checks out. So the next is 54, because if we go ahead and we find out this is going to be 36, because there's 180 degrees in a triangle, meaning this is going to be the next biggest one, or the mama bear, the in-between, the middle. So notice x is less than 8, but the y is the smallest, and so again, this is the smallest. So that's how we can use our triangle inequalities to check to make sure you could do this right. The other thing you can do to check, we can do our triangles inequalities, which I just talked about, or you can use your Pythagorean theorem because these are all right triangles. So this would mean that we're going to go ahead and get 6.472 squared plus 4.708 squared is equal to 8 squared. Now, because these are estimations, we're going to get really, really, really close to 0. It might not be perfect, but as long as you're close, and I mean really close to 0, that means that this checks out, because there is going to be some rounding approximations, okay? So, ladies and gentlemen, let's go to our next one here. Alrighty. So, in this next one, this is my 90-degree box. Oh, let's do it in a color we can see. So that means this is the hypo. Here is my theta, so that means this is the closest, so adjacent. And last but not least, the farthest away, opposite. So notice I'm still using, I'm going to pause here just for a second. Sorry, I had a text message I had to respond to. Thanks for being patient, because you didn't really do anything. But now we're back. So we're going to go ahead and do our lovely little deal here. Sine, cosine, and tangent. Let's find out which ones we can't use. So opposite and hypo have our x and our y. So that would go with sine. So we can't use sine. So we're going to use cosine, and we're going to use tangent here to find our other sides. So I'm going to do cosine of my theta is adjacent over hypo. And so I'm going to get cosine of 40 degrees is 6.5 over y. So we're going to put this over 1, cross multiply. So 1 times 6.5 is going to give us 6.5. And then cross multiplying the other way, I'm going to get y times the cosine of 40. Now, since we're solving for y here, my friends, I'm going to divide both sides by the cosine of 40. So I'm going to get y is equal to 6.5 divided by the cosine of 40. And once again, we're going to do this in one fell swoop in our calculator here. So we're going to go ahead and do 6.5 cosine 40 degrees. Oh, sorry, I forgot my divide. I was like, something looks weird. Divided by the cosine of 40 degrees. There we go. And I'm going to get y is equal to 8.485. All righty. So now let's go ahead and use our tangent. So tangent of our theta is going to be opposite over adjacent. So the tangent of 40 degrees is opposite, which is x, over adjacent, which is 6.5. So we'll put this over 1. 1 times x is going to be x. Cross multiply this way. We're going to get 6.5 times the tangent of 40. I always love it when I get to just put it in one fell swoop in our calculator here. So x is going to be 5.454. So let's go ahead and make sure our answer makes sense. So 40 degrees means this is 50. So this x has to be the smallest. So let's double check. Is x the smallest? Yep, we're good to go. So is y the biggest because it's the hypo? Yep, it's the biggest because it's the hypo. So we can use our triangle inequalities once again to really help us and get to the answers to make this a little bit easier. Okay? So, ladies and gentlemen, we're going to take a look at number 3, and then I'm going to show you how to do this 2 ways. So the first way is the way I would do this, which is, my friends, using your special right triangles. This is a 30. So that means this is going to be a short leg. This is going to be the hypo. And this is going to be the long or the middle, depending on which verbiage you use. So if I have my, because notice our 60, if I have my 60 to go 60 to short, I'm going to go 9 divided by a root 3. So we'll rationalize. You get 9 root 3 over 3, which is 3 root 3. And then to go from short to hypo, remember, you just double it. Don't need to open up my email. So that was x. So y is going to be 2 times our x. So 2 times 3 3 root 3, which is going to be 6 root 3. And then I would call this good. It doesn't say that you have to round your decimals. If you do, just put them in your calculator. How much easier is that? That is so easy. Alrighty, so that's how I would do it. Now, since this is trig day, let's go and erase all this. Erasing, erasing, erasing. And we'll do it the same way. So this is our 30. So that means that go opposite. This is my hypo. Closest here to my 30 is going to be my adjacent. And then farthest away is opposite. So we're getting the same idea here, sports fans. So notice I have, whoop, I don't know why that moved up so quickly. This is opposite over hypo. So which one is going to have an opposite and a hypo? That means, ladies and gentlemen, we cannot use sine once again. So I'm going to use my cosine of 30 degrees. So notice that's going to be adjacent over hypo. So we'll cross multiply and get y cosine 30 is equal to 9. So y is going to be 9 over cosine 30, which is going to go ahead and give me 10.392, or 6 root 3. Those are the same decimals. If you plug them in, same thing. Okay. Now for our tangent of 30 is going to be opposite over adjacent. So we'll put this over 1. And so I'm going to get x is equal to 9 tangent 30. So x is going to be 3 root 3, or our decimal, which is 1.96. Cool? So, again, use whichever way you want. I like my special rights because I don't need a calculator. I feel like it's shorter, less possible issues that arise. But, again, either ways, it's up to you. You can use your triangle inequalities to make sure you're good. Notice that our y is our hypo here, as we can see right here. It is our largest, so life is good. All right, my friends, hit the pause button. Try this one, number 4. It's our last one. Excuse me. Second to last one here. Just want to make sure we are good to go. And then, ladies and gentlemen, we'll go ahead and get this party started. Welcome back. So if this was me, I would go 45, 45. So we know that's an isosceles triangle, so this is 12. And then to go from leg to hypo, I would just do 12 times root 2, which is 12 root 2, or 16.971. Done and done. Special rights. Love them. Now, if you did the trig functions, that's okay. So I'm just going to erase this. This is still my hypo. This right here is going to be my adjacent side because it's closest to the 45. And then this right here is going to be my opposite. Now, notice I have nothing here for my opposite. So when I go ahead and I do this, because I'm looking for only one variable, I'm just going to use one trig function. I'm going to use my adjacent, which was the A, and then my hypo, it's a cosine type of day. So cosine of 45 is going to be adjacent over hypo. So I'm going to put this over 1. So 1 times 12 is going to give me 12. Going the other way for my cross multiplying, x times tangent of 45 is going to be x, not tangent, cosine, cosine 45. Then we'll divide both sides. And so x is going to be 12 divided by the cosine of 45, which again is 16.971. Boom. Done. Cool. Alrighty, last one here. We're looking for the dimensions of this rectangle. So the dimensions are going to be length times width. So basically I'm looking for this side here and this side here. Alrighty, so I'm going to focus just on this triangle right here. So I'm a huge fan of redrawing our triangle, especially in our next unit of notes, next section. That's going to be super important. So here we go. So this is going to go ahead and become my hypo. We can see that pretty clearly because it's opposite my 90-degree box. So then closest to my theta is going to be the adjacent side. And so this has to be opposite. Notice, even though we're getting the hang of this, we still label our triangles and we still write out our sine, cosine, and tangent relationships. So I have x over y, so I don't want opposite over adjacent. So no tangent for us. Alrighty, so let's start with sine. So sine of 61 is going to be x over 13. So we'll put this over 1. So x is equal to 13 times the sine of 61. Put that in our calculator. Hopefully you guys are getting pretty good at this point. It's 11.37. Alrighty, then we have our cosine of 61 is going to be y over 13. We'll put this over 1, cross multiply. We're going to get y is equal to 13 times the cosine of 61. So y is going to be 3.878. So let's go ahead and write these realistic dimensions of length times width. So our length will be 11.37 by our width, which is 3.9. That's our answer. So ladies and gents, hopefully this was helpful, and we'll catch you on the flip side. See you guys.